Algebra Chapter 1, Lesson 5, and we want to wrap up this lesson by looking at what we call like terms. And this is going to be very important. Again, it seems like I say that a lot, it's going to be very important, but I don't know, it seems like everything's very important as we go through these new things that we're learning. But like terms is going to be very important to simplifying these algebraic expressions that we're looking at. And that's, again, one of the main things we want to be able to do in mathematics is to take something that's maybe a little complex and get it down to its simplest form. And we're always going to be doing that. And we've talked about our final answers always being in simplest form or conventional simplest form. So adding like terms is another way we want to do this. So we want to look at what makes terms like, what makes them the same. Like terms, it says as we look up here, have exactly the same variable factors. And the word exactly is very important, as most words are. If we are trying to be precise in our language, exactly means exactly. It has to match exactly. Nothing can be different. Okay, so when we're looking at four like terms in an expression, we're looking for terms that have the exact same variable factors. Variables being a letter, and then again factors, we're talking about multiplication. So let's look down here at what terms are like and what terms are not like. As we look at the column here on the left, these are like terms, and to determine whether terms are like, we're looking at the variable factors of a term. So here we have a product, 3 times x, and remember, things that are being multiplied together are called factors. So 3 and x are factors. To determine like terms, we're not looking at the coefficient, we're just looking at the variable. And the variable factors must be exactly the same in order for them to be like terms. So if we look at the variable here, we have a variable x with an exponent of 1. And it's important to notice, even though it's not written there, it has an exponent of 1. And this term also has a variable exponent, a variable factor of x with an exponent of 1. So these would be like terms. The variable factors are exactly the same. If we look at this second example we have here, this is an x squared. So for them to be like, this would also have to be an x squared, which it is. Here you have x and y as variable factors. And notice here you have x and a y as variable factors. The variable factors are exactly the same. Here you have an x squared, and here you have an x squared. Here you have a y cubed, and here you have a y cubed. So again, all of the variable factors are exactly the same. So what makes terms not like? Let's look over here. In the first example here, you have this term has a variable factor of x. This has a variable factor of y. These are not the same, therefore these are not like term. The variables are different. One's an x, one's a y. Here we have a y. They're both y's, but notice the difference. This has an exponent of 1. This has an exponent of 2. The exponents are different, and this is very important. This is where a lot of mistakes are made. These are not like terms, because even though the variables are the same, the exponents of those variables are not the same. Therefore, these are not like terms. Here we have y, and here we have xy. Okay, this one does not have an x, this one does, so the variable factors are not exactly the same. They're almost the same, but they're not exactly the same. Here we have an x squared with a y, and here we have an x and a y squared. And be careful here because this variable term has an exponent of 2. This matching x has a variable exponent of 1. So they're not exactly the same. And the y squared are not exactly the same. So to kind of summarize this then for our notes, like terms have to have the exact same variable factors. All of the variables have to be exactly the same, and that means the variables have to be the same, and the exponents also of those variables have to be exactly the same. So here we have some examples of like terms. So again, the most important thing about noticing like terms is to make sure that the variables and their exponents have to be exactly the same. If anything's different, then they're not like terms. Okay? So let's look a little bit deeper then here at this bottom paragraph here where it says an algebraic expression is in simplest form when it has no like terms in it. Okay, so when you are asked to simplify an expression, how do you know you're done? Well, one of the things you want to look for is to make sure that there are not any like terms in the expression, because if there are, you can add those together and make them one. Okay, and we're going to use the distributive property in reverse in order to do that. Okay, and so we're going to show you how to do that. So when we look at an expression and we're asked to simplify, if it has like terms, we have to combine those. Okay, we cannot leave those. All right, so in simplest form, we're going to use the distributive property in reverse to combine those like terms or to add those together or subtract them. All right, so let's look at how we do that.